Question 12. Fill in the following table. This is a table of absorbance, P0% T, and concentration. Okay, they're basically a few equations that we need to set down in order to make sense of this. First of all, the percent T is equal to 100% times the light power P divided by the blank power P0. Right? P0, this is the blank. And then the absorbance is equal to the negative log of the transmittance T, right? And so I guess T we should define as P over P0, right? Percent T is 100 times that. Absorbance is the negative log of that value. And absorbance is also equal to epsilon times C, which are sample-dependent things, times the light path B, right? So I should say epsilon and B are going to be fixed in this experiment because epsilon and B are subject of the sample. And then the concentration is what we're looking to change in the sample. So let's see if we can fill in some values here into this table. We have light power and blank power for all of the samples. So let's just see if we can fill in the percent T here. So the percent T, if the light power is 1 and the blank power is 1, and that's 100% times 1, which is 100%, right? Then if we have 0.5 and 1, this is 50%. 0.1 over 1 is 10%, 1%, and 0.1% transmission. Now, the absorbance here is the negative log of the transmittance, right? So the negative log of the transmittance, which is 1, is equal to 0, right? The log of 0, or the log of 1 is 0. The log of 0.5 is about 0.3, I believe. Just make sure there. 0.5 base 10, base 10 log of 0.5 is 0.3. Yep. So it's minus of minus 0.3, so this value is 0.3. All the rest I can do fairly easily, right? Because the log of 0.1 is minus 1. Minus of minus 1 is equal to 1. 0.01 is, that's 1 over 10 squared. So this is, the log of this value is 2. This is 1 over 10 cubed. So the log of that value is 3. Okay, so here is where we're going to take over with this formula here. We know the concentration, in this case, is 1 millimolar. So A over C is equal to epsilon times B. So therefore, epsilon B is equal to 1,000 units of molar per centimeter, right? So now the concentration is going to equal to A over epsilon times B, right? So A over epsilon B here is 0.001 because epsilon B is 1,000, right? So this is A over epsilon B is equal to 0.002, right? And so with the trend here is 1, 2, and 0.003. So you can see how the light power is falling by decades, and the absorbance signal is simply increasing linearly there by 1 to 2 to 3. So let's see here. This is going to be 0.0003, right? Because this is a lower absorbance, and this will be 0.